I'm going to record. I'm going to go back to share. All right. So this is being recorded for the folks who can't be here. And hi, Kai, and whoever else joined. Good morning. Happy Tuesday. I'm going to try to keep this as much like a quote unquote regular class. My goal is to do a warm up with you this morning. Make sure the learning target is that you can tell me the different types of plate boundaries and be able to answer an FRQ, at least a piece of an FRQ at the end. This actually comes from an old AP exam. Can you guys do me a favor? Unless you have a question, mute your mic because we're getting I'm hearing a lot of background noise. So that way it doesn't have as much interference. Thanks. And please, please unmic yourself at any time if you want to ask a question, or I can unmic you too and ask you a question, make you talk to me. But while you guys are hopping on, there is a warm-up in front of you that hopefully everyone can see. What do you know about plate tectonics? And I tried to go over it because it didn't show up real great when I transferred this. So I typed, as you can hopefully see, there's A, B, C, D, and E. And there's 3 questions down here. So if you just take a moment and think about those, whether or not you want to write it or not. I'm going to pause for about 30 seconds or so, which is really hard for me. But I'm going to pause and let you guys see if you can pick the letter. And remember, on questions like these, although we're not having multiple choice this year, but you could use them once, more than once, or not at all. Okay? So I'm going to pause and let you see if you could answer 1, 2, and 3, and then I'm going to call on some of you. Okay, we ready? Can you give me a thumbs up if you think you got the 3? I see a thumb. Let's see. A couple people. I can only see so many of you at one time. All right, anybody feel brave and want to do number 1, the location where new crust is being created at a divergent plate boundary? And remember, this is just a warm-up. If you don't know it right now, just like a warm-up in regular class, not the end of the world. Hopefully by the end of this, you will know it. Anybody want to unmute themselves, or can I pick somebody? Go for it if you want to unmute yourself. Be brave. Let's see. Kevin, can you answer for me? Oop, I tried to unmute you.
I'm muted.
What's your answer for number 1? What do you think?
I don't really know.
Okay, that's okay. That's a good answer. It's kind of why we're here this morning. If you don't know, you want to make a guess?
I'm gonna say B.
Okay. Unfortunately, it's not B, but that's okay. That's a good guess. Anybody else want to guess? Thanks, Kevin.
Is it C?
It is. Is that Lily?
Yeah.
Yeah, it is C. It is C. So if you weren't sure of that, or it was a complete guess, we need to talk about that. I don't know if you guys know, but that is probably the most famous example of a divergent plate boundary. And some of you may know it's called the Mid-Atlantic Ridge. So I'm going to show you that in just a moment. So again, if you didn't know it, that's okay. That's why we're just warming up. We've been out of the building for week 3 now. We're starting, so no biggie. Number 2, the location where one tectonic plate is being forced beneath another, creating a volcanic arc. Any brave takers? And thanks, Kevin, for being a brave taker, even though I put you on the spot. Anybody else want to be a brave taker on number 2? Frank, you want to answer number 2 for me?
Here's Daniel.
What do you think?
Are we guessing which letter?
Yeah.
Is it A? I know there are a lot of volcanoes in Hawaii.
You're close. I mean, it definitely A. We're going to come back to that one. It's not A though, but that's okay. So this is obviously pretty tricky for some of us. We don't remember some of our plate tectonics and some of those things, but that's a good guess. Anybody else want to try to chime in on number 2?
Is it D?
It's not D.
I think it's E, right?
It is E. It is
Yeah.
E. And for those of you over here, I can point, it's a little hard to see. This isn't the highest quality picture, and I'm going to show you one in a sec. But this is what we refer to, and I'm not referring to Johnny Cash, but this is the Ring of Fire over here. It's a huge subduction zone, and there is this whole, and it's not quite a ring. Honestly, it's more like a horseshoe. But we'll talk about that in a sec. But that is the Ring of Fire where we have over here with E. And then last but not least on our warm-up, the intraplate location where hotspot volcanism is occurring. So I'm going to give you a hint. It's not C and it's not E. So now you're down to A, B, or D. Who's brave?
Is it A?
It is A. Whoop, whoop. It is A. It's the Hawaiian Islands that Frank was just mentioning, where there are volcanoes, and you were right on that, right spot on. So we'll talk about what that hotspot means in just a sec. So I'm going to stop this share and go over here, and I'm going to share something else with you now. And you guys, can you tell me, are you able to see both me and the PowerPoint?
Yes.
Yes.
Am I like a little, I don't know what you're seeing because I'm seeing something completely different. But just like a normal class, I'm not going to stand here or sit here, I guess, suppose, and talk to you for hours. Just like a normal class, I was trying to keep this today with a warm-up. Then I'm going to go through this presentation, and then I'm going to we're going to do a quick little exit ticket with an old FRQ from about, I guess it was 2014 or 2015. It doesn't matter what year, but there was a plate tectonics FRQ. So I have a couple pieces of that I pasted in here. And then I'm going to sign off if you don't have any questions and let you guys go work on the gizmo. So, and you can do that gizmo at your own pace, but the gizmo will just hopefully reinforce what we're talking about here. Keeping in mind that I don't know if the FRQ, on this year's exam is going to have plate tectonics, but this was one of the objectives in Unit 4, the Earth systems, that doesn't really fit in so much with any other unit, so it's kind of standalone. And then I threw one other objective in here at the end that you'll see. So I'm going to get right into it, and hopefully stop me, okay? If you have any questions, or I'm going to move this little box here. If you have any issues, just give me a shout out, and I can hear you all. I can't see you all at the same time, so I'm just going to kind of make sure I stop. Okay. We're going to start with the most obvious, I think, and probably one of the simplest of the three boundaries, the plate boundaries. And let me back up a sec and just go back to your Earth Science days, which I know for some of you guys was probably 8th grade, right? So we're talking 8th, maybe 9th grade, but you may recall that there are these plates that kind of float, if you will, on top of the mantle. They're moving ever so slowly. And there's three basic different types of plate boundaries. And if you've already done the gizmo, then you've probably already reviewed these, and hopefully this will just kind of come back to you. But if you think about the words, and I had to get on here and do this live because I have to talk with my hands, but to diverge is to kind of separate, obviously. And you can see this nice animation right here where you can see what's happening really with the mid-Atlantic ridge. So when we talk about seafloor spreading, what's happening is as the two plates are pulling apart, these are two oceanic plates pulling apart, that hot magma is coming up through the middle. Whoops, I didn't mean to click that. Hang tight, going back. That hot magma is coming up between the middle, and it's forming that ridge. And as you can see in the animation, they're diverging at a really, really slow rate. But over time, we are getting new crust being formed. And if you think about it, the Earth in the 4.6 billion years that we believe it's been around, based on radioactive dating of rocks, the Earth hasn't gotten any larger in size. So as we're generating new crust at a place, say, like the Mid-Atlantic Ridge, we obviously have to be destroying crust too. So, in order to keep the Earth not from continually growing, even though it seems really minute. So these divergent boundaries can result, as it says, in seafloor spreading, literally as you see. They can also sometimes, it can cave down in. So instead of that magma coming up, we can get little caves, and you get these little, as it says on the screen, rift valleys. And they can also be responsible, but not as frequently, for volcanoes and or earthquakes. We can talk about those more in a sec. Right here is just like the warm-up, that letter C on the warm-up, that famous Mid-Atlantic Ridge. If they're going to ask you about a divergent boundary, it's typically going to be that one. So just wanted to make sure. So I'm going to pause. Any quick questions on divergent boundaries? Chime in, yell at me like you would in class.
Are there always going to be volcanoes right at those ridges?
No, not necessarily. As a matter of fact, these are not usually associated as much with volcanoes. It's more going to be the subduction zones I'm going to talk about in a sec.
Okay.
So if you were going to ask a question, like I've gone back through all the released AP exams. Keep in mind, guys, this is one little very, very small piece, but I didn't want to just not cover it in the instance that, oh gosh, they ask you something about it. And you're like, oh, I haven't reviewed this since 8th grade. Typically, they're going to ask, you know, you're going to see on the FRQ, they're going to ask about these common ones, the Ring of Fire, the Mid-Atlantic Ridge, the hotspot volcanism in Hawaii. Those are the ones that seem to come up over and over again. It's not an earth science test, so don't stress too hard, okay?
All right.
Any other questions on divergent before we move on to the next one?
So Ms. Daniel, so when they diverge, they're diverging away from one another?
Yep, exactly. So they're moving apart. So just like if you think about, I don't know, driving down the road and the road diverges or splits, it goes apart. To diverge is to go apart. So literally, you know, if nothing else, just use your hands and kind of imagine going this way. There's some people that have tried, I watched some YouTube videos in years past where they take like graham crackers and either, I don't know, Cool Whip or whipped cream or something, and they try to model the graham crackers are the plates and try to do this. So if you really, I was going to try to do that, but it looks super messy. And I thought, we're not going to do that. Okay, I'm going to move on. We can go back if you have any questions at the end. I'm going to move on to the next one. This one's a little bit more complicated. A convergent boundary, but it is the complete opposite of the divergent in that obviously if divergent is spreading, convergent is coming together. This little animation right here is kind of neat. What makes this one a little bit trickier than a divergent is because when the two plates come together, it depends what those plates are. Are they two oceanic plates? Are they two continental plates? Or are they an oceanic and a continental plate? And typically, if you imagine two things coming together, the lighter one is typically going to slide over top of the more dense or heavier one. And when that happens, you get what's called subduction. That one plate is going underneath the other. This little animation that I'm showing up here in this upper left of the 4 quadrants, this shows obviously a continental to continental plate. And this is how you would form like the Swiss Alps or the Himalayas. These two plates are coming together. Imagine taking 2 graham crackers and smushing them together. It kind of, the crust, as you can see here, just kind of rises and you get these mountain chains. So this can result in the creation, as it says over here, of mountain chains. Typically when you have this continental to continental like that, okay? We mentioned with the warm up this ring, oh, by the way, sorry, down here directly below this is just a picture showing the continental to continental and the formation of those mountain chains, okay? Over here, these 2 pictures show a little different something, okay? The Ring of Fire, this is where 2 plates are coming together. And again, I said it's more like a horseshoe than it is a complete ring. Apparently there's some dormant volcanoes down here that complete the ring. And of course we have a transform fault over here along the west coast of North America, which we'll talk about in a sec. But predominantly over here where you have this island arc. And what's happening is, again, when that plate, and you can kind of see it down here, the oceanic plates are a little bit heavier. So as they subduct or go underneath that continental plate, you get these trenches like the Marianas Trench. These trenches are usually parallel to an island arc, okay? So these volcanic arcs usually form parallel to the trenches. So the trench forms right there where the plate, the oceanic plate is subducting. And then as it does that, some of this magma, sorry, I'm trying to get my cursor. Some of this magma is forced up and forms these obviously volcanic islands, hence the Ring of Fire. So typically, oh, I hope you can't hear my dog barking in the background, sorry. You have this ring of this volcanic arc and a trench that usually follows right along next to it parallel. So this is kind of, like I said, whereas divergent is where crust is being created, convergent is more like where crust is being destroyed. And you have these 3 different types. Often the continental, when you're doing the gizmo, if you haven't already done it, this is called collisional. So it's when they collide. The oceanic to continental or oceanic is more the subduction. But all of them together are still considered convergent boundaries, okay? Questions on convergent? Lucy has a question. No questions? Okay, if you think of one after, let me know. Transform boundaries, these are probably, I don't know, the simplest, not that the other two are that difficult, but if divergent again is that spreading and new crust being formed, if convergent is coming together where we're kind of subducting and crust is being destroyed, transform using my hands is where the two plates are slipping. Obviously, sometimes they're called slip faults. They're slipping past each other. Okay, I don't know if you can see my hands. Can you see my hands? I don't know. I can't see myself, so I have no idea what you're seeing. But obviously, the most famous transform boundary is right here, California. This is the San Andreas Fault, the site of many earthquakes. You can imagine that there's a lot of friction and a lot of stress when these two plates are sliding past each other. And there's a lot of buildup of pressure over time. And when that stress overcomes like a locked fault, it literally boof as the little kind of yellow, I don't know if those are stars or little booms, as those release all of that pent up or built up energy over time, then you're gonna have an earthquake. So transform is just those two plates slipping past each other. And this is typically, not to say you can't get an earthquake at one of the two previous plate boundaries, but this is typically where you're gonna see your earthquakes at a transform boundary. And it's why, of course, California is notorious for those earthquakes. Questions on that one? Pretty straightforward. Okay. Wanted to mention hotspots because they typically will sometimes ask questions about these. And I know, Frank, you were mentioning, you knew Hawaii. Most of us have never been one of these days, not anytime soon. These volcanic islands. And this is kind of cool. I wish I could put this in motion. But if you imagine what's happening here is you've got this magma plume, okay, this mantle plume that's releasing magma towards the surface of the earth. And this plate here, the Pacific plate, is sliding, obviously very slowly over top. The plume is stationary. It isn't moving, but the plate is sliding. So what you can imagine is this volcanic island right here is the baby. It's the newest, okay? As this plate is sliding, these are going to be the newest islands. Over here on the far left are going to be the oldest islands because this isn't moving, but yet the plate, this is intraplate movement. The plate is just sliding ever so slowly over top of that stationary plume and releasing that magma, forming those volcanic islands. So these would be the baby or the youngest of the volcanic islands, the middle children, if you will, and then the oldest as the plate continues to slide in this direction towards the northwest. And you can kind of see that a little bit cut off down here, but you can see, you know, 5 million plus years versus I guess that's 1.3, a little hard to read that. But that's a beautiful example. The Hawaiian Islands, definitely volcanic islands. It's not a subduction zone though. That's that ring of fire over, you know, off the coast of the Philippines and Japan, that arc that starts there. That's a result of that oceanic plate subducting and the magma coming up. Okay, questions on hotspots? No questions? Let me look at you guys. Are y'all still with me? Everybody awake?
Yes.
Mm-hmm. Yes.
I see a couple of you. I'm just kind of scrolling. I don't even know how many of us are in here with us. Good morning to those of you that joined after I started. And thanks for joining. So those are the three major boundaries: transform, convergent, divergent, and then I wanted to mention the hotspots, which isn't a type of plate boundary, it's a type more of a plate movement. So let me show you, oh, one more thing, hold on here. Let me minimize where you guys are. Whoops, I wouldn't be able to see you, but this obviously just shows you some of the plates and plate boundaries that we talked about. For those of you that joined after the warm-up, you can always go back and watch. I'm going to figure out how to post this. But of course, you can see, and I don't know if you can tell with those little arrows there, but it shows the arrows. There's that divergent, and of course it's green, and there's a key down at the bottom as another clue. But there's that mid-Atlantic ridge, that divergent plate boundary right there that we talked about. Over here, over, you've got this Philippine plate. That's the plate that's subducting, and you get that. You can see here the two arrows are coming together. And again, color kind of is the clue. It's that bluish color. So you can see that that's that convergent boundary where you're going to get those trenches and those island arcs, those volcanic arcs. And then, of course, the pink are some transform plate boundaries. Here's the rest of that ring of fire in this transform plate boundary, that San Andreas Fault right over there in California, with the Pacific plate and the Juan de Fuca plate up there kind of sliding past each other. Okay. Oh, Frank, I like your background. I feel like I wish I was there right now, wherever you are. I can't figure out how to do backgrounds on the computer. I know when I got on my phone on a Zoom meeting, I was able to change my background, but I cannot for the life of me figure it out. You guys, I'm going to be real upfront with you. I don't think, and I'll know more on Monday, I hope, I don't think you're going to get a whole lot of plate tectonics on this shortened AP exam this year. But I just wanted to make sure, I want to show you, here's a little practice. Here's one that was from, again, I think it was 2014 or 2015, doesn't matter. But you can read with me. Japan, Indonesia, and the Philippines are examples of volcanic island chains that have formed along subduction zones between plates in the Western Pacific. Part one, I believe this was just a one-pointer, might have been two. Describe what happens when two tectonic plates collide along a subduction zone. I want you to take about 30 seconds, try to formulate something in your head, and then just like the warm-up, if someone's willing to share, or if I can unmute somebody, what happens when two tectonic plates collide along a subduction zone? So take a moment. Let me make you guys a little bigger so I can see who I want to pick on. Just kidding. Anybody want to try? No reason to, I know nobody really usually wants to talk on these. Nobody? Allende, Nasia, Tiffany, Addie, who else we got there? Zach, Sundis, Brianna, Kai, Anya, Lily. I already called on Frank and Kevin. We'll make Nadia, Marissa, Dominique, Lenny. Just saying hi. Hi, Jaden, Nicole. Nobody? All right, well, I'm not going to put you on the spot. I won't do that to you. But hopefully you formulated something in your head, or maybe even jotted something down. Describe what happens when two tectonic plates collide. I'm not looking at the scoring guidelines right now, but I guess me, I always teach with my hands. Immediately when I think of subduction, I start doing this. I start, okay, when two plates collide along a subduction zone, one plate is going to buckle or slide underneath the other. I might talk about creating a trench. I might even go into more detail, but let's see what they say. One plate is literally pushed beneath the other, or, again, you could say the heavier plate, and again, the oceanic plates are typically heavier, can't speak. They're the ones that are going to go underneath. A trench, again, right there where it starts, you're going to get that trench, that deep, like the Marianas Trench. You don't have to go into much description on volcanic arcs. We're going to talk about that in the second one. But again, when they collide along subduction means below. One is going to go underneath the other. So pretty straightforward, okay? Any questions? Question is, could you have gotten your point? Let's say it was, I don't remember if that was a 1 or 2 pointer. I think it was just a 1 pointer. I'd have to go back and look at that year. Think to yourself, would I have gotten that point? And then the second part of that one, you can clearly see, explain how that subduction leads to volcanic activity. Anybody want to give that a shot?
As one goes down and shifting under, it's melting. So that means the mantle something else has to form on the other side. Beautiful.
Exactly. I mean, you would obviously type that. You guys are going to be typing your responses. And I know someone else was concerned about this. I believe you can handwrite your responses too and submit them. So I'll get you more information, but this year is going to be very interesting. But certainly if you were handwriting this or typing it, you'd want to make sure you explained. And so exactly what Frank said, and I highlighted in red, and this one I did put the points, 2-pointer. 1 point for saying exactly what you said, Frank. You were spot on. One plate is being pushed down. Again, I can't help it. Sorry, guys, with my hands. And as that plate is being pushed down and melted, you said that melted, that molten material or magma has to go somewhere. And so it will start to rise to the surface right near. So it, again, usually a trench forms right parallel with that volcanic arc. I believe there's, the Aleutian Islands off of Alaska, there's a trench. I don't know if it's referred to as the Aleutian Trench or whatever. I think it might be, but there's always, it seems to be a trench right there along that volcanic arc. So exactly what you said, Frank. I think I'd be pretty prone or inclined to give you 2 points on your response. So good job. One other quick thing. I don't think they're going to ask. It wasn't in the CED this year, but this is often where you have tsunamis. This is, and some of you may remember some of the most famous tsunamis right over there near the Ring of Fire. But when you have that subduction zone, you can often end up with these deep waves that start and obviously do some devastating damage. So any questions on that, on the FRQ? I didn't put obviously the whole thing. The rest of this particular FRQ went into succession, which is definitely something you need to review. Ecological succession, primary and secondary. And I forget what else was in this one, but I picked just the part that was on plate tectonics just to show you that they could ask something about it. So I certainly didn't want to leave it out. And some of you have already done, I hope, the Unit 4 personal progress check, and you may have noticed, or if you haven't, I believe I'm going to open those back up again, especially for those of you who have committed to still taking the AP exam. Thank you so much for getting that information to me. But I think I'm going to open those PPCs again, especially so that everyone gets them done. But Unit 4 was the one that had some of this stuff that you might have been like, ooh. I know I got a couple little remind messages. Miss Daniel, I don't remember this stuff. Like, don't fret, don't fret. One other thing that is completely not related to plate tectonics, if you've done your Unit 4 personal progress check, you may have come across some questions about rain shadows and been like, I looked to see in the one class about 50% of people missed it and about 50% of people got it. So I was planning on doing a little more with climate when we got to climate change in Unit 9, but they're not testing Unit 9. I'm going to cover Units 8 and 9 after the AP exam because colleges are still telling us as AP teachers, if we're going to give these kids credit, they are still expected to know the content. And of course, how do you take AP Environmental Science and not know climate change? I don't know, but we've covered it a little bit along the way anyway. But anyway, let me just briefly touch on rain shadows and make sure you understand. And this kind of goes back to the El Nino thing too a little bit when we talked about El Nino. And I'm glad we had already done that because that's something you definitely need to know. But remember that as the Earth is rotating, we have that uneven heating of the Earth's surface, and that leads to those prevailing winds, like, for example, the southeast trade winds, the northeast trade winds, the westerlies, they're named after where they originate. This diagram, I kind of want just to make sure you understand. You can kind of see this mountain here, this island, and you've got, as you can see here, this warm water blowing in, or excuse me, not what water, the warm wind blowing in. As that warm wind blows in, what it's going to do naturally through convection is it's going to rise, okay? As that warm air rises, it's going to cool, condense, and obviously you're going to have some precipitation. And what's happening here, I just lost my arrow. What's happening then is this cooler, drier air is going to descend down what we call the leeward. So the windward, as it's clear that this is where the wind is coming in from, the prevailing winds. The warm air rises. As it cools, releases that moisture. Then the cooler, drier air descends over here on the leeward side. Hold on, I'm going to move. And it's called a rain shadow. And to me, it's kind of like, oh, your shadow. It's this geographical feature is blocking the rain. So you've got a shadow over here, this rain shadow, and over here on this side of the island, it's going to typically be very dry and arid. So just want to make sure that you saw there were a couple questions, I believe, in the Unit 4 personal progress check on rain shadows. It's just a matter of those prevailing winds and convection, releasing that moisture, cooler, drier air coming down, leading to a more arid climate on this side of the island. So the windward versus the leeward side. So wanted to throw that in there because it really didn't fit in too many other places. So other than with climate, and like I said, we're not really covering climate change right now. So it has been longer than I wanted to keep you, but thanks for hanging in there. Before I let you go, are there any questions? I'm going to stop the share here and go back to you guys. Any questions for me on what we just covered or anything else? I'll open it up real quick before we sign off. Your assignment, like if we were in class, I'd say, okay, now go get on your Chromebooks and practice with the gizmo. I'll address one question. Someone said to me, I don't think the person's on here right now, where do we turn in your plate Tectonics gizmo? And I'm going to be real upfront with you. I'm like, I don't need you to turn it in. I need you to do it because you want to learn and because, you know, it's a review. So if for you, you want to just take notes on it, you want to just play, if nothing else, go in the gizmo and you get to play. It'll review, transform, convergent, and the different types of convergent, the collisional and the subduction. So, you know, I guess at this stage of the game, until I can start taking grades again, it's kind of an honor system and I want to learn, so I'm going to do it because I want to and I want to do well. And it's for me, not because Miss Daniel's given me a grade. Now come fourth quarter, friends, all bets are off. Then I get to start putting in grades again because you have to get a fourth quarter grade. So for example, those personal progress checks, that will be counted. So please, please don't blow those off, okay? Questions about what we just went over or anything else before I let you go?
So with a transform boundary, can it also be like a convergent and divergent boundary? Like, can it push like together as it's like sliding?
To be honest, I've never heard of that. Not going to say it's not possible. I'll have to go check it out. But from what I understand, and I've always understood, it's the transform is when the two plates are sliding past one another, you know, anti-parallel. So they're not doing this, you know, in no collisional or subduction, just kind of that slipping past one another. So I would say that probably not, but earth science was never my favorite subject. I always joke the earth science teachers, who studies rocks? Ugh, I was such a bio geek. As a matter of fact, you guys, like I said, in about an hour, I'm going to geek out with some sloths at the Toucan Rescue Ranch down somewhere near the equator. At least if I can't go anywhere, I'm going to pretend. But Lily, I hope that answers your question. Anybody else?
How do you want us to submit the PPCs?
So that's another great question. And I think Marissa, if she's still on here, Marissa asked me this and I thought, oh, good point. Because originally I said to you guys in class, you can submit at the end after May 11th. And I don't even know when the test dates. They might keep the original plus offer another one. You can submit a handwritten, like for me, I would have to handwrite. You have two options still. You could still handwrite it. Did you guys all know the new trick that you can use? I don't know if it works on anything other than iPhone, but you can go into your notes and scan and it automatically makes a PDF of your work. My son, who's obviously a junior, you guys know at college, scans everything on his phone and submits his homework because it's all like huge problems. So if you still want to handwrite it, you can absolutely scan it into me. Or even worst case, I guess, take pictures of it and submit it. If you prefer, you can open a Google Doc and just start, you know, Unit 1, your score, and just kind of mirror what I put on there. You can open that up and just kind of type in. One other thing, kind of piggyback on there, I'm kind of not forcing the NIMSY thing. I've been talking to Miss Wong, Mr. Leonard, Miss Barcroft. The four of us have our own little group chat. I'm supposed to be in a 6.5-hour conference call for NIMSY. Let's just say I might not be on it. But NIMSY is offering optional review sessions. I posted the link in the folder that says APES Review. So I'll just say to you this, like if you did terribly on personal progress check number 2, the Living World Biodiversity, NIMSY has a Living World Biodiversity session coming up in April that you could log on to. But guys, I'm going to start doing my own. After this week, I'm going back and starting over the course, and I'm going to start the review. So I decided for me, some teachers are going ahead and teaching units 8 and 9. I'm not right now. I'm going to start reviewing and get you ready for the AP exam. You've committed. There's a chance to earn $100. You've paid your $42.50. You're in it to win it. So let's get you ready for that AP exam. And then after, units 8 and 9 are my favorite ones. It's like garbage. It's water pollution. It's climate change and ozone depletion. It's the heart of the class, to be honest with you. I don't know how you test without studying those things. So again, colleges are telling us we better teach it, but it's not going to be tested. So I'll teach that in the fourth quarter, because fourth quarter starts April 27th. Any other questions? You guys rock. I think there's about, I don't know, 15, 20 of us on here. So thank you, thank you. I'll be doing the same thing this Thursday on some other new material on watersheds, and then we'll move into review mode. So if you have no more questions, I hope you have a great rest of your day. Go play with Plate Tectonics Gizmo, and hopefully I'll see you Thursday. I miss you. Take care of yourselves. Stay at home.
We miss you.
I miss you guys.
Bye, Miss
Oh,
Daniel.
Miss Daniel.
Yeah.
Wait, go ahead, Nasia.
Oh, I was just saying bye.
Oh. Bye.
You should watch San Andreas, that movie with the it talks about those tectonic plates.
Oh, does it?
Yeah, it's a really
All right,
good
and all
movie.
I guess I better watch now. I have some movies. I started Tiger King, you guys. Have any of you watched that?
What's it about? I've heard about it, but I don't know what it's about.
It's a train wreck. It's a docu-series on big cats and murder, mayhem, and madness, and that's probably the best way to describe it. It's bizarre. I'm only 2 episodes in, and I can't tell you I like it, but I'm intrigued enough that I want to finish now. I had to find out what the hype was all about. It's weird, though. Anyway.
You guys should all watch Contagion. It's a really good movie.
Oh, yeah. It's pretty scary and appropriate right now, huh?
I'll wait.
You know what's crazy is that we did infectious disease, if you remember, back in December when I did environmental health, and that's technically part of Unit 8, so it won't be tested. And a lot of teachers in my little APES group are like, oh my gosh, I've got to teach infectious disease. I'm like, well, we already did that. So we talked about SARS and MERS, but never in my wildest dreams did I. And I remember someone asking me, what's the difference between a pandemic and an epidemic? I don't think anyone will ever ask me that again. That's alive right now. Yep,
Wait,
this is the
what's the
pandemic, 2020. And I feel like it's March 97th right now. I can't believe it's only March 31st, but.
Wait, I know we're in a pandemic, but is epidemic like?
All right, an
It's like
epidemic.
Pandemic is global. Epidemic is more localized.
Oh, okay.
Yeah,
Epidemics in one area. Pandemic is different areas across the world.
yeah. Yep. And I don't think even the World Health Organization has an exact line that, okay, we've officially, I remember when they announced, okay, it's officially a pandemic, but, even they were saying, I don't know exactly what constitutes, is there a certain number of countries? Oh yeah, boom, now it's a pandemic, but certainly stay healthy, stay safe, and stay inside, I guess, unless you're going to get fresh air. Lily, I might see you if you run by the house, wave. I don't think anyone else lives close enough to run by my house. If you do,
It's kind
drive
of
by,
funny. I
wave.
have a few times, and I'm like, "There's Nathaniel."
Did you
pretty
see?
But everything's
Yeah,
pretty
we're
good
doing
over here,
little
though.
things in our neighborhood. People put out little animals in the trees.
No, yeah, I saw that, and my mom was telling me about
Yeah,
that.
it's fun. All right, guys. I know you probably have better things to do.
Never. We miss you.
I miss you guys too. I'll be back Thursday.
All right. Bye.
Okay.
Bye.
Have a good day.
You too.
Bye.
Bye.